Section 5.3, Multiplication of Polynomials. So first, just a little bit of review. Distributive properties. If we have a times the quantity b plus c, that's a times b plus a times c. And so if we had negative 7 by 3 plus 9x, applying the distributive property, we would have negative 21 minus 63x, right? Because a negative multiplied by a positive is negative. A negative multiplied by a positive is negative. And similarly, if we have subtraction within the quantity, we are still allowed to apply the distributive property. And so if we had a times b minus c, we would have a times b minus a times c. And so if we had 6 by 4y minus 13, 6 times 4y is 24y, minus 6 times 13 is 78. Some rules for exponents. If we had a to the m times a to the nth, that's a to the m plus n. So x to the 4th times x to the 9th is x to the 4 plus 9, or x to the 13th. A to the m to the nth power, power to a power, you multiply the exponents. So x to the 4th to the 9th is x to the 4 times 9, is x to the 36th power. And if we had a product to a power, a times b to the mth power, we get a to the mth times b to the mth. And so if we had 5x to the 3rd power, it would be 5 cubed x cubed, or 125 x cubed. Before we can multiply polynomials, let's make sure we can multiply monomials. So if we had negative 7x squared multiplied by 9x, it's all multiplications here, we're allowed to rearrange and regroup using those commutative and associative properties. So let me rearrange it as negative 7 times 9 times x squared times x. Negative 7 times 9 is negative 63. X squared times x is x to the 2 plus 1, using our product rule for exponents, and that would be x to the 3rd. Why don't you try these other two on your own? Six b to the 6th times 3b to the 5th. Rearranging, I'd have 6 times 3, I'd have b to the 6th times b to the 5th. 6 times 3 is 18, and b to the 6th times b to the 5th would become b to the 6 plus 5. So we'd have b to the 11th power. 7x times 5x is 7 times 5 times x, 35, x squared. So that's how you can multiply monomials. Now if you can multiply monomials and use the distributive property, then you can multiply a monomial by a polynomial. For example, if I had 4x cubed being multiplied by the polynomial 3x squared minus 6x minus 7, applying the distributive property, I would have 4x cubed by 3x squared minus 4x cubed by 6x minus 4x cubed by 7. Alright, now that we've applied the distributive property, I would have 4 times 3 times x cubed times x squared minus 4 times 6 times x cubed times x minus 4 times 7 times x cubed. So I'd have 12x to the 5th power minus 24 x to the 4th power minus 28 x to the 3rd power. Why don't you try the other two on the slide on your own? Now would be a good time to pause. Applying the distributive property, I would have negative 9x by 4x squared minus negative 9x by 3. So that would give me negative 36x cubed. Negative 9 times 4 is negative 36. X times x squared gives x cubed. And then I'd have minus a negative 27x. I would write plus 27x. We don't write minus a negative. Negative 6x by 2x cubed plus 1 would be negative 6x by 2x cubed plus negative 6x by 1. Negative 6 by 2 would be negative 12. X by x cubed is x to the 4th power. Plus a negative 6x, we would write minus 6x. So a little bit more practice. Why don't you try these three on your own as well? Now would be a good time to pause. Ten by the quantity 1 minus 6x, just applying the distributive property. 10 by 1 is 10, minus 10 by 6 is 60x. So 10 minus 60x. 1 minus 2x squared by 3x squared. Apply the distributive property to both terms. All right, apply that 3x squared into both terms. So I'd have 1 times 3x squared minus 2x squared by 3x squared. So that would give me 3x squared minus 6x to the 4th power. N squared by negative 5n squared plus n minus 2. Applying the distributive property, n squared by negative 5n squared plus n squared by n minus n squared by 2. N squared times negative 5n squared, well, that's a 1 times negative 5, negative 5 n to the 4th power plus n squared times n is n cubed minus n squared times 2 is 2n squared. So we now know how to multiply a monomial times a polynomial. So now how do we generally multiply polynomials? To multiply a polynomial and a polynomial, multiply each term in the first polynomial by each term in the second polynomial, and then combine like terms if necessary. Alright, so let's take this example, x plus 5 times x plus 9. So first I'll take this x and I'll multiply it by each term in the second polynomial. Basically all I'm doing is I'm distributing it. So x times x plus x times 9. Then I'm going to take this plus 5 and distribute it through the second polynomial. So I have plus 5 times x plus 5 times 9. So I now have x squared plus 9x plus 5x plus 45. Or more simply, x squared plus 14x plus 45. Let me do another example. Z plus 6 times 2z minus 1. Alright, so that would give me, distributing the z, I would have z by 2z plus z by negative 1. Now taking the 6 through, plus 6 times 2z plus 6 times negative 1. Z times 2z is 2z squared, plus z times negative 1, that would be a minus z. 6 times 2z would be a plus 12z, and 6 times negative 1 would be a minus 6. Combining the like terms, I'd have 2z squared plus 11z minus 6. Why don't you try this next one on your own? Find the product, 7x minus 6 by 9x plus 2. Alright, so I would have 7x by 9x plus 7x by 2 plus negative 6 by 9x plus negative 6 by 2. So I'd have 63x squared plus 14x minus 54x minus 12. Combining like terms, I would have 63x squared minus 40x minus 12. Let's look at a couple that are slightly more complicated. So now we have a binomial being multiplied by a trinomial, but the idea would be exactly the same. If I had 3x plus 5 by 4x squared minus 3x plus 2, first thing I would do is take that 3x and distribute it through all three terms in the trinomial. So I'd have 3x by 4x squared plus 3x by negative 3x plus 3x by 2. Then, taking the plus 5 and distributing it through, I'd have plus 5 by 4x squared plus 5 by negative 3x plus 5 by 2. Simplifying, 3x by 4x squared would be 12x cubed, and then we'd have a minus 9x squared. 3x by 2 is 6x. 5 by 4x squared would be plus 20x squared. 5 by negative 3x would be minus 15x. And 5 by 2 would be a plus 10. Combining like terms, I'd have 12x cubed minus 9x squared plus 20x squared. That would be plus 11x squared. Plus 6x minus 15x would be a minus 9x. And then a plus 10. Why don't you try this one on your own? B minus 3 by b squared plus 3b plus 9. Alright, applying the same idea, I would have b times b squared plus b times 3b plus b times 9 plus negative 3 times b squared plus negative 3 times 3b plus negative 3 times 9. Simplifying gives a b cubed plus 3b squared plus 9b minus 3b squared minus 9b minus 27. Notice that plus 3b squared minus 3b squared, those go to 0. Plus 9b minus 9b, those go to 0. And so I'm left with b cubed minus 27. FOIL is another method that we can use to multiply only if we have two binomials. And the idea is we multiply the first outers, inners, lasts, and then we combine like terms if necessary. But remember that this will only work if you have two binomials. So if I had y plus 6 times 2y minus 7, firsts, y and 2y would go to 2y squared. Outers would be the y and the minus 7, minus 7y. Inners would be the 6 and the 2y, would be plus 12y, and the last would be the 6 and the 7, negative 7, excuse me, which would give you a minus 42. Combining the like terms, we would have 2y squared plus 5y minus 42. Alright, why don't you try the last one on your own? Use either of the two methods. Alright, using FOIL, x by x is x squared. X by 11 is 11x. 4 by x is 4x. And 4 by 11 is 44. Combining like terms, we would have x squared plus 15x plus 44.